VOR is short for Very High Frequency Omnidirectional Range. It is a type of short-range radio navigational system for aircraft, enabling aircraft to determine their position and stay on course by receiving radio signal transmissions. On the left side of the Columbia VOR is the VOR identifier. Here you can find the name, frequency, channel number, the three-letter identifier, and the Morse code signal. On your navigation log, next to the checkpoint column, is the VOR column. Write down the Columbia VOR three-letter identifier, the frequency, and the Morse code signal. Use a VOR perpendicular to your course. This is because your VOR receiver in your aircraft determines angular information of the VOR transmitter on the ground. A VOR perpendicular to your course gives an accurate radial position. Identify the exact location of the VOR. To find a VOR at an airport, refer to your legend. An open dot within a hard surface runway indicates a VOR location. Place your plotter on the map and line it up with the VOR station, and then line it up with your departure airport. Read the radial on the compass rose of the Columbia VOR. Here we see the identifier is covering the compass rose, so read the 2 indication to the VOR. It reads 87 degrees. By adding 180 degrees, we get a 267 radial. To clarify, I am reading the compass rose on the map and not the plotter. This will be the departure airport radial from the Columbia VOR. Next, find your second checkpoint and line up the VOR station with your second checkpoint. Read off the compass rose the radial of your second checkpoint. Write this down on your navigation log. Line up your plotter with your third checkpoint, the railroad track. Ensure the other end of the plotter is lined up with the Columbia VOR. Read the radial from the Columbia compass rose. It should indicate a 254 radial from the Columbia VOR. Write this down under the railroad track in your checkpoint. Let's move on to our next radial checkpoint. Find the divided highway on your course. Line up your plotter with the divided highway and with the Columbia VOR. Read off the compass rose your radial from the Columbia VOR. This radial reads 246 degrees. Write this down on your navigation log. Go ahead and find your 5th checkpoint and line up your plotter with that checkpoint in the Columbia VOR. Read off the compass rose the radial from that VOR station and write this down on your navigation log. Now line up your 6th checkpoint with your plotter. It should be the power transmission line. Find the VOR station at Columbia Airport and line up the white dot with your 6th checkpoint. Write down in your navigation log the radial of the power transmission line. It should be 235 degrees. Use your plotter to line up the Harbor Airport checkpoint with the Columbia VOR. The compass rose from the Columbia VOR reads 219 degrees. Write this down in your navigation log. Now line up your plotter with the destination airport and the Columbia VOR. Read off the compass rose the radial from the Columbia VOR and write this down on your navigation log. We have a 196 radial from the Columbia VOR to the destination airport. We have now found all of our checkpoints and the radials from a VOR for each of those checkpoints. Determining cruising altitudes can be difficult and confusing at first to pilots. Just remember, when your VFR course is 0 degrees to 179 degrees, it will be an odd number plus 500 feet. However, odd cruising altitudes do not start until 3,500 feet. If traveling west anywhere from 180 degrees to 359 degrees, your altitude will be even numbers plus 500 feet, starting at 4,500 feet. I'm choosing a cruising altitude of 5,500 feet based on distance and winds aloft. Departing RCM, we will need to climb to a cruising altitude of 5,500 feet. In the altitude column, draw an arrow pointing up to indicate a climb. On your navigation log before reaching your destination, draw an arrow down indicating a descent. Next, look up the destination airport field elevation in the airport facility directory and add 1,000 feet for pattern altitude, and write this down on your navigation log. On your navigation log, in the bottom right-hand corner, is the airport frequencies. Write down all of your departure frequencies using your airport facility directory. Look up your destination airport and use your airport facility directory to write down all the airport frequencies on your navigation log. Using your airport facility directory, look up the airport for which you'll be landing and draw a sketch of the airport on your navigation log. Write down the runway length and width and the field elevation, along with taxiways and where the terminal is located. Refer to the airport facility directory to find out traffic patterns for each runway and draw them on your sketch. Now we need to use our course and weather information to find our compass heading. You can either call a weather briefer or use do-lots for a weather briefing. Get a standard weather briefing for low altitudes and fill in the appropriate boxes. You should fill in your departure and destination airport, your aircraft identification, your cruising altitude and direction of flight, the time of departure in Zulu, and the duration of flight. Use METARs and TAFs for your departure and destination airports. Use a winds aloft chart to find out the wind direction and velocity at cruising altitude. Ensure there are no TFRs in your route of flight. In the wind column, write down the wind direction and velocity along with the temperature. Become knowledgeable in diagnosing weather information. Knowing wind direction at all altitudes during your flight will aid in correcting headings once established at cruising altitude. Also, when climbing and descending, wind direction may change as well as velocity. There is no such thing as too much information when it comes to weather on or near your route of flight. Use your flight computer to find your pressure altitude. Write down your airport field elevation along with the altimeter reading to get your pressure altitude. This will be needed on the charts to follow. Using your Cessna 172 information manual, find the temperature and pressure altitude you'll be cruising at and find your calibrated true airspeed. Temperature at my cruising altitude is 19 degrees C. Standard temperature is 15 degrees C. So I'll be using the standard temperature column. Now choose a pressure altitude nearest to your cruising altitude and choose an RPM setting. Follow the table down to the cruising altitude. Once you have chosen an RPM setting, find the calibrated true airspeed. Cruising speeds are shown for an airplane equipped with speed fairings. Without speed fairings, decrease speed shown by 2 knots. Write down the true airspeed in the true airspeed column. Here we see 118 knots. Return to the table to find the gallons per hour of fuel used and write this down in your navigation log. Write down the fuel burned in gallons per hour and the cruise RPM setting for quick reference during flight.